Welcome back students. Unit 1 Electrostatics. Today's topic is electric field. Okay. Already we discussed Coulomb's law. Interaction between the 2-point charges were discussed there. The force of attraction or repulsion is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Okay. So action at a distance. The force of attraction or repulsion between the 2-point charges is known as action at a distance. Okay. So how the charge Q2 knows the existence of charge Q1? So for that, Michael Faraday introduced the concept field. Every charges in the universe, they create electric field around the surrounding space. Okay. While the charge Q2 is bringing nearer to the electric field of charge Q1, it experiences some amount of force. That force may be attractive or repulsive based on the nature of force. Okay. So based on the nature of force, it may be attractive or repulsive. Right. So 2-point charges Q and Q0, they are separated at a distance of r. Q0 is placed at a point P. Q is known as source charge, Q0 is known as test charge. So I am going to calculate the electric field of source charge Q by using this test charge Q0. I bring the test charge from the infinity distance towards the source charge Q and placed at a point P. Now I am going to calculate the electric field of source charge Q. Right? So according to Coulomb's law, I write the formula F vector is equal to K Q naught divided by R squared R cap. So the force is directly proportional to the product of the charges and inversely proportional to the square of the distance. Okay, right. So K is the proportionality constant. Right. So the electric field of source charge E vector on the test charge Q0 at the point P is equal to F vector divided by Q0. The force acting per unit charge is known as electric field. That is equal to, I am going to substitute the formula of Coulomb's law here. F vector is equal to K Q0 divided by R squared R cap. So K Q0 divided by Q0 into R squared R cap. So Q0 get cancelled. Finally, I get K Q divided by R squared into R cap. Okay. So E vector is equal to K Q divided by R squared into R cap. Right. So the electric field is vector quantity because it have both magnitude and direction. It have both magnitude and direction. Its SI unit is Newton per Coulomb. Okay, so Newton per Coulomb. Based on this formula, force per unit charge. So SI unit of force is Newton, charge SI unit of charge is Coulomb. Newton per Coulomb is the SI unit of electric field. Okay. Now the important aspects of electric field is going to discuss. Right. So first important aspect, if the charge is positive. Okay. So if the charge is positive, the electric field is pointing away from the source charge. It is the source charge. The electric field is pointing away from it when the source charge is positive. If it is negative means the source charge is negative means the electric field is pointing towards the source charge. It is the first aspect. Second aspect. So F vector is equal to Q0 into E vector. So already we discussed E vector is equal to F vector divided by Q0. Electric field is equal to force acting on a test charge per unit test charge. That is equal to force equal to Q0 into E vector. Okay. It is the another form of Coulomb's law. It is in terms of electric field. Okay, it is in the term of electric field. Okay, already we discussed between the 2-point charges. Okay, Coulomb's law between the 2-point charges, interaction between the 2-point charges. Here the electric field is included in terms of Coulomb's law. Okay, it is Coulomb's law forming. Okay, right. So E vector is independent of Q naught. That means electric field is independent of Q naught. Okay, so here the formula. So E vector is equal to KQ divided by R squared into R cap. So KQ divided by R squared into R cap. There is no test charge here. Okay, so the electric field is independent of test charge and depends on the source charge. Okay, another one reason is the magnitude of test charge will be lesser than the magnitude of source charge. Okay, so another aspect, point charge Q is placed here. It is a positive charge. It is known as a source charge. I consider 3 points from the source charge, 3 different points, P, Q, R. Okay, so P is nearer than R and Q, right? So electric field of point P is EP vector, Q is EQ vector, R is ER vector. Okay, so the magnitude of EP vector is greater than ER vector and EQ vector. Why? Because the distance of P is smaller than the R and Q. Okay, so R is far away from the source charge. So the magnitude of EQ vector is much lesser, right? So P at point P is in the nearer distance, so the magnitude of EP vector is greater, right? So the distance is increases, electric field is decreases. Okay, so if the distance is decreases, the electric field is increases, because the electric field is inversely proportional to the square of the distance. Okay, already we discussed the magnitude of touch charge will be lesser than the magnitude of source charge. Okay, right. So this formula, which formula, E vector is equal to KQ divided by R squared into R cap, this formula only valid for the point charges. Okay, it is only valid for the point charges. It never obey for the system of charges. Okay, so finally, important aspect, kinds of electric field. Okay, so first, two kinds of electric field. One is uniform electric field, another one is non-uniform electric field. Uniform electric field means it have constant magnitude and same direction. Okay, if the arrow mark having the same magnitudes, they are pointing a same direction also. That's why it is known as uniform electric field. Non-uniform electric field means it have different magnitude and pointing different directions. Okay, whether it is different in direction or different in magnitude, or both are different. Okay, both are in different, they are coming under the category of non-uniform electric field. Based on the magnitude and the direction, it will be decided uniform, whether it is uniform or non-uniform electric field. If the magnitude is same and the direction is same, means it is coming under the category of uniform electric field. Both are different or any one is different, means it is coming under the category of non-uniform electric field. Okay, right. In this session we discussed what is electric field. Okay, what are the important aspect of electric fields, right? If you have any doubt, means ask me. Okay, thank you.